Hey, good afternoon, everybody. Welcome to LRVS 2022. And we are knee deep in day one. We are almost halfway. Everything's going great. And let's get to our next speaker. His name is Jake Mazulewicz. Forgive me, Jake, if I mispronounce it. Jake is PhD director at JMA Human Reliability Strategies. And Jake is going to be, his topic will be 7 practical steps to build a culture of human reliability. So there will be chats available. Jake is not present at the moment, but with the chats, we can log him. And so maybe Jake can get back to anybody on the app, but I'll make a note of the chats if any questions. Also, please don't forget to be sure to check in with the code. Check the code on the screen to redeem your points for the LRVS game challenge. Okay, let's get going. Thank you very much and enjoy the video. Thanks.
Hi. So you all are experts in mechanical reliability, which is wonderful. But there's a whole different type of reliability that I think you might be interested in, as I've become interested in it over the past 10 or 15 years or so, which is human reliability. And in the next 30 minutes, you're going to hear why human reliability follows a very different set of rules and principles than mechanical reliability does. So let's jump into it. Here's the first thing and the most important thing to know about human errors in the world of human errors. To err is human, right? Everyone makes errors, no matter what degrees you have, no matter how much training you have, no matter how many years of experience or service you have, no matter where you've worked, how many countries you've worked in, and no matter how hard you try, everyone makes errors. I don't know of a single exception to this. If you do, please email me and let me know. One study out of Australia said that humans tend to make about 2 to 4 errors per hour every hour that we're awake, and about double that if we're stressed or fatigued. So errors happen all the time. So let's put a number on it just to keep things interesting. How much do the top 500 businesses, or the biggest 500 businesses in the US and the UK, how much do they spend on workplace errors every year? It's a tough question to kind of wrap your head around, and it was for me too. Here's the answer. About $37 billion a year, billion with a B. So that's quite a bit of money. And keep in mind, that's only the top 500 businesses, which can afford to do seminars and workshops and great conferences like the one that you're at right now. Think about all the smaller businesses, mid-sized 10-person businesses, where one big error, one big incident could mean the end of that whole company, right? So $37 billion a year. That's one reason why I have been studying errors for the last 10 years or so. So the big question seems to be this. So how can we effectively balance error-prone human nature with increasingly complex and expensive and hazardous workplaces like the ones that you all work in? That's the question that's been fascinating me for more than about 15 years right now. So many companies try to eliminate errors, and they can't. I show leaders and high hazard companies why errors are signals, not failures, and how to address the deeper problems so that everybody can work more reliably and safely. That's what I try to do. So how do I do that? Well, there's no single solution. If there were, you would have heard about it right now, right? If there's one secret ingredient or one thing to do, we all would have heard about it right now. So what I've found is, like the solution to many different complex problems, the best solution to the problem of errors in organizations, high hazard organizations, is what an old mentor of mine called a consolidation of subtleties, doing several things together. That tends to make the difference. Now, I'm going to show you the 7 things that I found that make the most difference. Do you have to do all 7? No, of course not. But the more of these 7 things that you do, the more likely you're going to be to get a successful, sustainable, proactive approach to errors, what I'll call a learning-based approach to errors. So here are the 7 practical steps. And keep in mind, this is a very, very quick overview. I go into more details in the presentations and the webinar series that I do. So number 1, take a learning-based approach. By the way, here's a quick summary on 2 pages of all of the information you're going to get today. You can scan it and download that. You should get that 2-page handout right there, and you're welcome to use that for personal use only. I do ask that you don't make that part of your company training programs or anything like that. For personal use, totally fine. Go ahead and scan that. So here's the first one, 2 approaches to errors. To boil down a lot of what's in many of those books you see behind you right there, there's really 2 different approaches that people in any organization can take to errors. The first one is the traditional, what we'll call a control-based approach to error. The second one, which is the one I'm advocating more of, is what we might call a learning-based approach to errors. The traditional control-based approach to errors, you're probably very familiar with. And it's basically saying we need to expect perfection. We need to expect everything to go right all the time. That's what we want. That's what we're aiming for. We're going to eliminate failures. Anytime anything fails, doesn't go right, we're going to do a root cause analysis, figure out what the failure is, and fix it. Now, if that's a human error, we're going to find the individual that made the error, right? It's a very thin line between asking what went wrong and asking who screwed up. And we're going to get rid of that individual like we would get rid of a defective part in a machine, replace it with a better working one, and move on. And in terms of the people that we have working for us, the people who advocate the control-based approach would say, we want more compliance. We write the procedures and the policies and the diagrams, everything that we have. We want people to follow those. And one of the first questions that people will get after an incident in a control-based company is, were you following procedures? That always starts an interesting discussion. We can go into that more a little bit later. A learning-based approach is pretty different. Here's how it's different. Instead of expecting perfection, people who advocate a learning-based approach will say, expect humans to be humans. Now, that doesn't mean do anything you want whenever you want. You can have very high standards, but expect humans to make errors, because that's how we've evolved. In fact, for thousands of years, humans have evolved by trial and error. Great. And if you actually said error out loud, even though I couldn't hear you, you get extra points for that too. So instead of eliminating failures, people who take a learning-based approach will say, let's expand successes. Let's find out how the jobs get done right 99% of the time, which is almost always not exactly by procedure, and let's expand those successes. Instead of blaming individuals and finding fault with individuals, people that take a learning-based approach will say, let's improve the systems. Don't try to change or fix individuals directly. That almost never works. And instead of increasing compliance, getting people to do what you tell them to do, people that take a learning-based approach will say, let's increase resilience. The idea that things are going to go wrong at some point, even with the most compliant people. And surprises are going to happen like COVID-19 that have nothing to do with errors. Let's build our systems, our machines, our teams, our cultures, our processes, our organizations, so that they can withstand errors and surprises and not get derailed by them. That's a nutshell. That's the core difference between the control-based approach and the learning-based approach in a nutshell. Now, I'm spending a little bit more time because this is really the foundation of everything else. We're going to move faster through some of the other details, but I want to give you this. Does the learning-based approach get real-world results? Well, for that, Let's go ask a guy named Mike Abrashoff. He was a naval commander who worked his way up through the ranks, literally. And finally, the day came when he got his own ship, what every Navy commander wants, the keys to his own ship. I don't know if they actually have keys or not. But in any case, the ship that he got, unfortunately, was the worst ship in the Navy. That's what some people had called it. It was the USS Benfold, a guided missile destroyer with 310 sailors on it. And when Abrashoff took over, it was a dumpster fire of in terms of safety. For example, they had, I believe, 31 safety incidents within the past year. Retention was at a pretty embarrassing 28%. Most of the people who had a choice to stay on the Benfold or leave wanted to leave because the culture was so bad. Abrashoff took over this ship and realized that it might be his only command. So he was going to go all in and try something pretty radical. Back then it was radical. Now it's getting less and less so. It was a learning-based approach to management of this very, very high hazard organization. And he did this learning-based approach. Instead of the command and control, he asked people, all right, how do you get this job done? How do you get that job done? What do we need to do to make this job run smoother, better, easier, safer? You tell me. I'm just the captain. You're the expert at doing the job. And this was a very radical approach for the US Navy or almost any military organization, but Abrashoff tried it because he didn't have anything to lose. The results were astonishing. Safety incidents went from 31 incidents per year to 2 per year. Retention went from 28% up to 100%. And in case you're wondering about it, the operational readiness of the ship went through the roof too. Costs of almost every project came in regularly under budget, sometimes significantly under budget, whereas before he took over, they were over budget. And the Benfold won the award for the most combat-ready ship in the entire Pacific Fleet, half of the US Navy. And you may be thinking to yourself, well, how long did this take? I mean, years, whatever? No, he did all of this, although Abrashoff would say he didn't do it. He would say, we did it together in about 20 months. And he said, these are his words, the more control I gave up, the more command I got. That's a very different take on command and control than you may be used to hearing. Don't believe me if you don't want to. Go read it in his book, It's Your Ship. That's on page 6. Again, those are his words. So that's one example of one leader taking a learning-based approach in a high-hazard industry, a high-hazard organization, and producing pretty spectacular results with it. So I'm curious to know your thoughts on the learning-based view of errors. And so go ahead and pull out your phone, do a scan on this. You'll actually get a quick poll. It's anonymous, of course. And go ahead and take it, and you'll see a screen like this come up afterwards. You'll see that link that says see previous responses. If you click on that link, you'll get the previous responses, whoever has responded to that poll recently, and it might be interesting for you to see. So I promised 7 practical steps. So for each of the 7 steps, I want to give you one practical takeaway. Here's the first one. After the next incident or error, before asking what went wrong, classic question, ask this question instead. How does this job get done right 99% of the time? I guarantee if you ask that question sooner or later to the people who actually do the job, you will find out things about that job that will change your context of what that job is all about. So that's your one practical step. And it's on the handout. I'll refer to this several times. Okay, we're going to pick up speed now and move forward because I'm just about halfway through the presentation. Second step in the 7 is to create psychological safety. Google several years ago did something called Project Aristotle. They studied about 180 of their own teams, internal teams, trying to figure out what made the best teams tick. What they found was something really surprising. The common element, the one common element that all the best teams had was something called psychological safety. They took the name from a woman, a researcher named Ames, Dr. at Harvard, and she wrote that psychological safety is the belief that you're not going to be punished or humiliated or shamed for speaking up with challenging ideas, uncomfortable questions, legitimate concerns, or honest mistakes. And psychological safety is transformational. It is really the foundation of building any good team. You can look up Dr. Edmondson's work if you like on your own. So here's one practical step for building psychological safety after an error or something unexpected happens. Instead of us saying, hey, Joe failed to do X, like failed to wear his hard hat or whatever, instead of saying what Joe failed to do, ask, what did Joe do? And why did it make sense for him at that time to do it? Look at it from Joe's perspective. And I think you'll find a very different context and learn a lot more about the incident, rather than just asking what went wrong and what should he have done and why didn't he do it. So that's one way to build psychological safety. There are obviously a lot more. So third step, assessing risks and hazards. This is a pretty complex module. In the workshops I teach, I go into this a fair bit. So for you all, and for the very short amount of time we have here, let me ask this. Is situational awareness, kind of awareness of emerging risks and hazards, situational awareness, is it important in your workplace? Assume it is. For most people, it is. So my next question then is, well, how do you build and maintain strong situational awareness? I mean, exactly, specifically, how do you build it? How do you do it? What's your model or technique or strategy? What do you use? And if you're thinking to yourself things like, well, I just try to pay attention, that doesn't quite count, right? It's not specific or technical enough. If you're like most people, you don't have good answers for these questions. You may say, well, I try to improve situational awareness, but I'm not really sure how I do it. Well, you're not alone. I wrestled with this and researched this on and off for more than a year before I figured out the best model for me. And I've been teaching it ever since then, more than 10 years now. I won't go into the details because it gets a little technical and we don't have the time for it right now, but I'll send you this. This is an article that I wrote with all the details you'll need to do the scan and focus model of situational awareness. I hope it's useful for you. You can get a link on either LinkedIn if you like, or on my blog. And if you scan, I believe that'll take you to the blog one, which is free, open to the world. Feel free to use it. That's the scan and focus model. And that, I hope, is going to be a good and unusual, unique, innovative way to help build awareness of hazards and risks. So number 4, and this is on applying defenses. 1935, might have been 37, is quite a while ago. The day before Halloween, Army Air Corps generals were testing out a new bomber, actually a couple of new kinds of bombers, to see which one they wanted to buy. And this was the one they were looking at and really had their eye on. And this is a photo of the actual plane from the 1930s. It was called the Boeing Model 299. And the pilots tended to really like it. It was bigger, faster, carried more payload than anything that had ever flown before, lots of new safety features. But when it got up into the air the first time, this is what happened. It crashed in front of all the generals, the engineers. Boeing almost went bankrupt. Everyone was stunned. How could this possibly happen? Well, I go into the details in the webinars. I give a lot more. However, the bottom line was something happened. One of the pilot had forgotten to move one switch, one safety feature, it forgot to release, and that basically crippled the plane and doomed it. They didn't realize it in time to save it. The test pilots afterwards, some of the smartest and most courageous people back in that era, said, you know what, if this can happen to our best test pilot who was flying the plane, it can happen to any of us. Doesn't matter how smart or experienced we are, doesn't matter how big our egos are. So they invented the pilot's checklist, something that had never been done institutionally before. And once they started using this pilot's checklist, the before and after was tremendous. After they started using the pilot's checklist, they did about 1.8 million miles of missions in World War II. To the best of my knowledge, 0 deaths from human errors. And that checklist is still in use today, over 80 years later. You show me a tool that's been in continuous use for 80 something years, and I'll show you one that actually saves lives and improves reliability. So checklists were one of the innovations that they used. And what we call today classic individual and team defenses, checklist is one of them. Peer check, 3-step communication, communicating before each irreversible step, confirming terminology. Those are all useful ones too. Very quick, simple, easy to use. And you can use them pretty much instantly. There's a lot of resources out there. And if you email me, I'll give you more resources and where to get them. But there's a big hidden flaw with using these kind of tools. Again, we're too short on time for me to go into the details, but here's another article that you can read that I just wrote on it. So go ahead and scan that and it should bring it up. If for any reason the technology doesn't work here, just throw me an email and I'll send you the link to it. So that's it. So one practical step on applying defenses: pick a job that you and your team regularly do and write or update a checklist for that job to include only the 4 or 5 or 6 or 7 items often missed. Don't make the checklist too long. That's one cardinal sin of it. Keep the checklist short, because that's how end users and operators benefit the most. And let me know how it goes. Throw me an email at jake@reliableorg.com and let me know how it goes. So number 5, improving processes. Now, you all in the specific work that you do, I think you all are better than almost anybody else that I teach and work with, because you get processes better than almost anybody else. But here's some processes on the human side. James Reason, who's written for 30 years on human error, said you can't change the human condition, but you can change the conditions under which human beings work. And that makes all the difference. So here's one quick example, bottom part of a ladder right here. So the problem is, when we work on ladders, many people still step on the top 2 steps of the ladders, like an A-frame ladder, even though OSHA says whatever you do, don't step on the top 2 steps of a ladder. But we all do it anyway. At least most of us do, and some of us are good liars about it. So the traditional person-based solution for this is more procedures, more rules, more training. Does that have some effect? Yes, it kind of makes you feel guilty when you step on the top 2 steps, but many people still step on the top 2 steps. What would a system-based solution for this look like? Very, very different. Make it hard to do the wrong thing and make it easy to do the right thing, like this. Design a ladder like this, which are now getting increasingly popular, that take away the top 2 steps, make it hard for you to do the wrong thing, and they make it easy for you to do the right thing, which is stand on this nice big black little platform right there, very comfortable compared to a small step. And the rim up at the top like that has a hook for your paint can, has a hole for your electric screwdriver, it has a can for your beer. Everything you need really is designed into that thing, even though you can't see it. I'm joking for work, of course, but the point is designers put a lot of thought into how end users can use this and use it properly. How much training do you need to use this? Virtually none. Instead of trying to change people's behavior, we just changed the design, and it made all the difference. So what about a process improvement or system improvement for a non-mechanical system? Something where you're not going to redesign a new device or ladder or tool or vehicle. A great example comes from UPS a few years ago. The problem was UPS drivers were getting maimed or killed when their vehicles got hit by other cars, or trucks were hitting them. There's not much you can do about other cars. And that's what stymied UPS for a long time. They're like, we're not going to paint our trucks bright orange or put them in reactive armor or anything like that. So what can we do? Well, the traditional person-based solution is more procedures, more rules, more training. But the UPS people, being very clever and thoughtful, thought up a different solution. You may have heard of it. They eliminated, or at least minimized, left-hand turns. Why? Because they realized, looking at the research and going over the processes and systems, they said, where most of the worst accidents happen is on intersections when you're making a left-hand turn. Going right, going straight's not too bad, but going left-hand turn crosses directly into another lane of traffic, and that's where we're getting T-boned and hit. So what if we just eliminated left-hand turns? Many of the drivers said, can't eliminate left-hand turns. And some of the route planners down in the basement of UPS headquarters said, give me a minute, right? And they worked out a new route that had minimal or no left-hand turns. And that's what they've been using since then. And what they realized in looking at the numbers was it was phenomenally successful. They didn't need to redesign anything, no streets. There's still the ugly brown trucks, they're around to stay. That's the way it goes. But they saved UPS $300 to $400 million per year and virtually eliminated serious crashes. Not eliminated, and they still get fender benders, but the serious ones that really change people's lives, they manage to be safer and more reliable at the same time. How's that for a win? And you might be interested to scan that and see the Michigan left. Michigan has been designing this idea into their roads for decades now. So those are a couple of good examples of system improvement that you may not have thought about and heard about before. So one practical step for you, pick a process that you and your team regularly do. I know you all work with mechanisms a lot. This may be something that you and your team do. And together brainstorm process improvement that would make it easier for your team to do the right thing in that process. And that's it. So is there more to that? Obviously a lot more. And again, I go into that in the webinars that I teach for companies. But this is just a quick overview. So number 6 out of 7 in just a few minutes we have left, building resilience. This is the really advanced stuff. So the hallmark of a high reliability organization, HRO, is not that it's error-free, but that errors do not disable it. Flight deck crews of aircraft carriers know that no matter how many procedures and rules they have, and they got tons, weird stuff is going to happen, right? Things are going to go overboard, planes, things like that. Things are going to happen that are unexpected surprises or errors. And at this point, the difference between an error and a surprise doesn't really matter that much. So what they do is build their systems, both their mechanical and their social systems, to be resilient. What do I mean by that? So let's take an example of fall prevention versus fall protection. Fall prevention, the philosophy used to be, fall prevention systems used to try to prevent the fall, prevent the error from happening. What we realized is that people are going to be really creative in how they figure out how to fall, right? And they're going to work around most of those systems. So what if we did fall protection instead? Take the concept of resilience and say, let's assume that people are going to fall. We don't want them to fall, but let's assume that somebody's going to fall off the edge of something. What's going to happen after that? How can we make it safer? Well, that's what they came up with. And if you wear a harness for work at all, you know kind of what this is. It's a self-releasing lanyard, like a big bungee cord that slowly deploys instead of just dropping you and then catching you on a steel cable, which can snap your back or your neck or whatever. This lanyard slowly deploys to bring you to a safe stop, relatively, statistically so, if you're falling more than about 6 feet or so. No system is perfect, but this one is a lot better than simply trying to prevent the error. You see the difference? Fall prevention was trying to prevent all errors. Fall protection was resilience. We assume that errors are going to happen. How can we make it livable and survivable so that error doesn't disable you? That's resilience. So one kind of interesting case study or business case on resilience: does building resilience actually create real world business results? Well, here's a fun example on this. UPS, again, this time on their fleet of planes. They have about 288 aircraft and they fly to about 11 different airports. And unwanted surprises, as you might expect, mechanical teams getting sick with COVID, something like that, or mechanical failures or weather are commonplace. And yet you still want those Amazon packages on time, sometimes the next day. So UPS figured out a long time ago, don't try to eliminate all errors, but instead have something they called hot spares. This is a small group of aircraft, 10, 12 aircraft, something like that, staged strategically all over the United States, ready to go, not on a moment's notice, because we're not talking about scrambling fighters from NORAD, but within about 2 hours or so. So once they get a call that says, hey, listen, flight 1042 into St. Louis, they're going to make it in there, but that plane needs to be serviced. It cannot go on to San Jose, California. What do you got? Well, we've got a plane, in Chicago that can make it to St. Louis, transfer everything and take it over to San Jose. We can have it ready in 2 hours. And that's it. So you may be thinking to yourself, does this really happen a lot? Well, in 2014, UPS deployed those hot spares 275 times. So quite a bit. And they wound up rescuing, as they call it, 1.5 million packages. And that saved them about $32 million in revenue in 1 year. So when it's done properly, resilience absolutely pays off at the highest levels. So that's a quick example of resilience. Your practical step for resilience: pick a process that you and your team regularly do. identify one serious error that's impractical to prevent, and together brainstorm one resource in reserve or a fail-safe that you can use to recover from that error quickly, easily, inexpensively, and safely. That's how to apply resilience. Again, this is just a quick overview. There's a lot more to the concept that I teach in the webinars that I do, but this is a quick overview of it. So you may be thinking, that's a lot of stuff, Jake, man, that's so many ideas. I don't know if I can apply them all. And you're not going to be able to apply them all, certainly not at one time. So we need some mechanism for you to kind of slowly practice a few and learn from experience. And that mechanism is after action reviews. Here's one in progress. An after action review is a non-punitive, semi-structured post-job debrief. It lets you learn from experience, not just when things go wrong, but when things go right, which is the main thing to do. The Army National Training Center said the principal learning experiences were the after action reviews. It wasn't if we have time, we'll do them, or sometimes they help. These were the principal learning experiences. And Peter Senge, who wrote the fifth discipline, the art and practice of the learning organization, he literally wrote the book on learning organizations, said the Army's after action review is arguably one of the most successful organizational learning methods yet devised. How do you do it? Here's your practical step. After your next successful project, gather the team together that did it, 5, 6, 7 people, 3, 4, 5 people, whatever. And within about 20 minutes, ask these questions. Number 1, what did we set out to do? Number 2, what did we actually do in this job? Number 3, how did it turn out the way it did? And number 4, what will we do differently next time? Notice there's no blame or fault or failure implied in any of those questions. It's all about learning. That's how to do learning or an after action review. Folks, that's a very, very quick overview of the 7 practical steps to build a culture of human reliability. I hope it's useful for you. If you have questions, throw me an email if you like at jake@reliable.org, or you can just scan this and stay in touch. Also, if you like what you got from me here today, scan this, send me an email, and we can get you more stuff and even have a conversation if you like. I hope the information is useful to you. Good luck and take care.